produced number of equations. And I would like to finish this lecture by defining what is a catchment, or a basin, or a watershed. Because of course it becomes very much important. You see that I'm continuously referring to the catchment. So it's important to provide a definition. So I would like to provide a couple of definitions. Catchment and another one. So catchment, what is a catchment? Now let me turn the light on. What is a catchment? The catchment must be defined with reference to a cross-river section. What is a cross-river section? Next definition. So wait a moment, but it's intuitive. A place along a river. So you get a river, and you get a place along the river, like a bridge or a city, and with respect to this section of the river, this place, you want to define a catchment. And the section is closed also the closure of the catchment, the section of the river. And so what is a catchment? Given an assigned cross-river section, which I will define in 1 minute, the catchment is a portion of the geographical surface such that all and only the water that rains over it drains towards the given river section. I read it again. The catchment is the portion of geographical surface such that, I forgot that, all and only the water that rains over it, over the geographical surface, drains towards the given section. Let me make a sketch. You have a river, you identify the cross-river section, and then you start looking at the geographical surface, and you ask yourself, okay, if it rains here, the water arrives at a certain time to transit, to pass from this river section. Yes, okay, this is part of the catchment. You go in another place and say, okay, if it rains here, where does it go, the water? And you may see that it goes in another place, another river section, so it's not part of the catchment. And so you identify a geographical surface so that all the water, and only the water, that rains here, goes through this section. It's important that you say all and only, because if you just say all the water, you are not excluding that other places would drain here, which is not acceptable. You should say all and only the water. There is an important consequence in this definition, that you are excluding groundwater contribution from other places. So the only input of water that you have to this system is rain. Because all and only the water that rains there goes here. So your only input of water is rain. It's a simplification, a big simplification. This is the catchment. I mentioned the cross-river section. I think you all know already what is a cross-river section, but let me remind you. You have a river. And if you take a point in the river, so a defined point in space which belongs to the river, to the water, here. Let me see. Let me draw like this. I take a point in the river. Of course, I have water moving there, and there is a velocity vector here. Because it's a river with water moving, so if I get a fixed point, I can draw a velocity vector. Okay, let me now take a plane which is perpendicular to its vertical plane. Let me take a vertical plane which is let me just think. I think I can avoid to say vertical. Let me take a plane that is perpendicular to this vector. Okay, just one plane as it's perpendicular to this vector, to this velocity vector. And the intersection between the river and this plane is the cross-river section. This is the cross-river section. So what is a cross-river section? Is the intersection between the river and a plane that is perpendicular to the velocity vector of water. There is one thing that you could ask me. You could tell me, yes, but if you move along the plane and you take another point, you have a different velocity vector, you may say. So you have a different definition of cross-section. No. Because by definition of river from hydraulics, and especially by definition of monodimensional river flow, you get that in the same cross-river section, the velocity vector is uniform. And this is a definition given by hydraulics. I don't want to go back to hydraulics. It's called gradually varied flow. Corrente gradualmente variata. It's an assumption that is always made in river hydraulics. The assumption is that the velocity vector is unchanging in the cross-river section. So once that you define the velocity vector, you draw the cross-river section and you are sure that the velocity vector is unchanging. Here, you have the same velocity vector. This is an assumption, of course. It's not true in general. It's reasonably true. Okay, now we didn't reply to the original question how to write this balance equation, and we will discuss on Monday. I anticipate to you that on Tuesday we will devote 3 hours to numerical exercise. Okay? So you have to take your personal computer with you.